In this video, we're going to review velocity time graphs. First of all, the slope equals the acceleration. If I were to pick, say, 2 points on my line and draw a triangle so I can find the rise, which is the change in velocity, and the run, which is the change in time, the slope, which is equal to the rise over the run, which is the change in velocity over the change in time, would represent the acceleration. Where this line intersects the vertical axes, this value right here would be the initial velocity. If the object is exhibiting constant acceleration, you're going to get a straight line. So for example, this line can be represented as y equals mx plus b. On our traditional y-axis, we're plotting velocity, and along our horizontal axis, we're plotting actually time. And our slope of our graph right here represents acceleration. And our y-intercept, or vertical intercept, represents the initial velocity. So you can rewrite this as v equals a times t plus v sub 0. If you have a line that slopes downwards, this would indicate that you have constant negative acceleration. At the point where these two lines would intersect, this would mean that at this particular point in time, they would have the same velocity. If you have a curved line in a velocity versus time graph, that would imply that you have changing acceleration. So this is like accelerating acceleration. So straight lines along here represent constant acceleration. This is constant positive acceleration. This is constant negative acceleration. But curvy lines represent non-uniform acceleration. If we were to calculate the acceleration in this graph, we would need to pick, say, 2 points like here and here, draw a line between these 2 points, and calculate the rise, which is the change in velocity, over the run, which is the change in time, which would get you the average acceleration. If you were asked to find the instantaneous acceleration at one particular point on the curve, you would need to draw a tangent line to the curve. Then calculate the rise over the run, and the slope of this tangent line to that particular point on that curve would be called the instantaneous acceleration. I believe I already mentioned this point that if you have a positive slope, then your velocity is increasing in the positive direction, which means you have constant positive acceleration. And if your slope is decreasing, you have a negative, that means your velocity is decreasing in the negative direction. If you have a horizontal line in the velocity time graph, that would mean that your velocity is remaining constant. It doesn't mean that you're stationary, it just means that you're moving at the same speed. If the line is above the axis, then that means you are moving at constant positive velocity. If the horizontal line is below the x-axis here, then that means you're moving at constant negative velocity. And remember that constant velocity means zero acceleration, because acceleration is the change in velocity for the change in time. And if the velocity is not changing, then the acceleration must be zero. Okay, now moving down to here, what does the area under the curve of a velocity time graph represent? Well, so imagine that a certain time has elapsed, like, I don't know, we'll say this is 5 seconds, and you're moving at a constant velocity of, say, 10 meters per second. If we were to drop a vertical line in here, and then shade in this area, the area of that box would represent, well, let's see, take a look at the units. It would be the height of this box, say 10 meters per second, multiplied by the width of this box, which is 5 seconds. And if you look at your units, the seconds will cancel out, and you'll end up with an answer of 50 meters. So it represents some sort of distance. Well, technically speaking, it represents the displacement. You can actually prove this mathematically. For example, in this particular situation, the acceleration is 0 because the velocity is not changing. And we can calculate the displacement by simply using the displacement equals the average velocity, or the velocity is actually the same, 10 meters per second, and multiplying by the time interval, because that's really what the definition of average velocity is. It's distance, or displacement, divided by time. So the area under a velocity time graph represents displacement. But what do we do with this example? We have some area above the axis here and some area below the axis. The area that is above the axis could be, say, 5 meters per second in this particular situation. So this is all distance that's being covered in the positive direction. But the area that is below the axis, this could be, say, negative 2 meters per second, this would be all movement that is in the negative direction. So this would be negative distance. So for example, if this was like, say, 30 meters over here, and this was I don't know, 20 meters, it would be considered negative, and so your displacement would be 30 meters minus 20 meters, which would be a total displacement of 10 meters. If we were to just simply add 30 meters and 20 meters here, we would end up with what's called the distance. So when you consider both areas as being positive, it's really how far you have traveled. It doesn't matter that as a vector quantity. You're just simply looking at the distance you walked, for example. But when you consider where you start and where you end, and you go as the crow flies, for example, then you need to consider area above the axis as positive and area below the axis as being negative. I think you're ready to try now example number 11.